So this is page 36 of your student journal. All right. And doing some notes today, or at least looking at the notes. You can reference this at a later time. But a conditional statement. Let's talk about all these different logical statements. Okay, Carla? You ready? You look pretty pumped up over there. You just really got to tame yourself and calm down. Okay? Don't get so excited about the math. All right. So, if we're taking a look at a conditional statement, it's a logical statement that has two parts. It has a hypothesis and a conclusion. The hypothesis we call the if part, and the conclusion we call the then part. All right? So if I'm taking a look and going, hey, I really have these two pieces that I want to deal with. The if, what we got here? The if part is our hypothesis, and our then part is our conclusion. And mathematically, the way we show that, we have some different symbols. If P, we're going to call P the hypothesis, and the conclusion Q. Okay, so if P, then Q. The symbol, this little symbol right here, that's how we write if P, then Q. Okay, in mathematical. It's read as P implies that Q happens. Okay, P implies Q. All right? So as we're going through this, and there's something that you may want to add some notes, remember you have these note areas. You know, the other thing we do with our conditional statement, our conditional, if you think of it this way, conditional is really our original if-then statement. Things that we do to that if-then statement, we start flipping things around. We start moving the hypothesis and conclusion. So rather than saying if P then Q, we switch it around and we say if Q then P. And we test it out to see what the truth value is for it. Okay, we call that a converse. All right, and we'll get to that here in a minute. But we also negate it. We negate it. We change its value. So we say things like if not P, then not Q. So if not this, then not this. Okay? We negate it. Okay, and the way we show negation, just to kind of make sure that we know some of the math we're going to be reading, when we say if not P or not P, we use this little symbol right here. Let me zoom in on like that. Okay? It's not really a negative symbol. It looks like a similar symbol. Okay? If not P, then, or in this case, not P. All right. So at the bottom of the page, related conditions. So let's check it out here. Here are the different things that you started looking at last night. If P, then Q. So in our regular conditional statement, we show it like that. The converse would be if Q, then P. And we'd rewrite it like this. And then when we do an inverse statement, the inverse is where we take our conditional statement. Okay, so this up here is our conditional statement. We take our conditional statement and we negate it. We say, well, if not P, then not Q. We add the words not in there. We make it opposite. Okay? And then if we negate the conditional, we're also going to negate the converse. When we negate the converse, that's actually on the next page. It'd be nice if it was on the same page, but it's not. It's at the top of the next page. It says, if not Q, then not P. We negate that as well. Okay? All right. I want you to read this paragraph to yourself. Just kind of take it in, and something we talk or reference maybe a little later in class. Yeah. There's some actually over by the that green jar over there. Okay, tell your neighbor what an equivalent statement is. What equivalent statements are. You know? When both are what? If they're both true or they're both false. Okay. Okay, we have equivalent statements if both statements are considered or true or both are false. Okay? If both things are true, if both the conditional and a converse are true, what we do is we can write a biconditional statement. And biconditional is a way of stating something using if and only if. Okay, it means that both my conditional and when I switch the hypothesis and conclusion, my converse are true. So in this case, P, if and only if, Q. So these are all the different types of statements that we're going to see today. So it doesn't mean a ton until you actually see them. And we're going to try some of them out here in a minute. But note what the symbol looks like. Okay? All right. So let's go ahead and try some of these. I want you, this is monitoring progress. It's problem number 1. It's in your textbook. It's not in your student journal, remember. So you're using your note page. Okay? What I want you to do right now is I want you, with your groupies, to complete number 1 and number 2. Actually, let's just do number 1 first, just to make sure we've got it. Okay, and if you don't have, it says to write the hypothesis in blue and identify, put the hypothesis in red and the conclusion in blue. If you don't have red and blue, then you can just use 2 different colors, or you can kind of identify it by boxing it or something. Yeah. It's not in your journal. Your monitoring progress are on your textbook. Oh, so like what page in your text? So how could you locate that? I don't know. But if you go to 2.1, I bet you can find it. Yeah, I know you can do it. All right, give them a go. All right, let's see how you did here. Okay, hypothesis in blue, conclusion. Oh, I did it backwards. That's ridiculous. Unbelievable on my part. Man, well, we're not going to use that. That'll really mess us up. Let's use this. There we go. Black and white. All right. So which one is my hypothesis? I better use the right colors. I blame my color blindness, but red and blue, I can actually see those 2. That's no problem. So if an angle measures 30 degrees, that is my hypothesis. Okay? My conclusion, I have acute angles. Okay? So if my angle measures 30 degrees, there we got it. And then it's an acute angle. Hypothesis and conclusion. All right, how many got it? Okay. How about the second one? 2x plus 7 equals 1 because x equals negative 3. So what's my hypothesis there? Yeah, Brennan. Good. Hypothesis is x equals negative 3. The conclusion is 2x plus 7 equals 1. Okay? Because x equals negative 3, 2x plus 7 equals 1. Okay, once again, you could actually, however you want to bring that to your attention. Okay, not sure how many you have, red and blue. Just, you want to make sure you don't do like I did and label them incorrect on my other page. All right. Any questions there? Yes, Alex.
Could you do for number 2, could you do if 2x plus 7 equals 1, then x equals negative 3?
Like switch it around? Say if 2x, well, not the way they're writing, it's because they're saying because this. They're saying this, that means this is dependent on that. Okay, because x equals negative 3. Okay, so 2x plus 7 equals 1 because x equals negative 3. So you have to have it in that order. Is that your question as well? Yeah, it's because we have the reliant word because on there. Okay? All right. Any questions? Okay, let's take a look at the next page here. Let's try, we already talked about negation. We talked about this guy. Let's try example 3. Let P be you are a guitar player, and let Q be you are a musician. Write the statement in words. Decide whether it's true or false. So A, B, C, D. Work with your groupies there. Write what they're stating right there in words. Hey, does anyone have A that I can put up here? Hey, just put your statement up.
I wrote it in the wrong spot.
You wrote it in the wrong spot.
Yeah, because here.
Oh, that's all right. Here. I can make that work. All right. So, do you mind that we evaluate? We won't tell whose it is. Okay. If you are a guitar player, then you are a musician. Let me move this out of the way here. Okay. If you're a guitar player, then you are. Man, that's really blurry. I don't know if that helped much. Okay. How many agree there? If you're a guitar player, then you are a musician. Yeah. It says if P, then Q. So very good. We have P is you're a guitar player. Q is you're a musician. Is that true or false?
True.
Yeah. Guitar players are musicians. So that's true. Okay. Anyone got B for me? Alex? Thank you very much, there, Maddie. Thank you, sir. All right. We don't want to spoil. We'll put B up there. If you are a musician, then you are a guitar player. And Alex says, nope, that's not true. Okay, so we just flipped them, right? So using his A here, we had if we are a guitar player, then we are a musician. We just switched the guitar and the musician, right? So Alex, what you're saying is if you're a musician, then you don't have to necessarily be a guitar player. Okay. What other musicians are there? Yeah. Pianists? Yes? French horn? Trombone? Yeah? 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 The tuba. Well done.
The flute.
Actually, that's part of my Wi-Fi password at home. I won't tell everyone because I don't want you to steal my Wi-Fi, but it has the word tuba in it. Okay. Yeah, it does. All right. Try to rip off my Wi-Fi. Okay, anyone have C? I haven't given you a lot of time, so maybe I better pause. Who's finished C? Who's finished D? Okay, let me pause for a minute and let you guys get C and D done.
I need more sugar. It makes me
All right. Hey, I am going to go ahead and put up Maddie's here. Letters C and D. If you are not a guitar player, so now remember, you're going back for your inverse. You're negating your conditional. So if you're not a guitar player, then you are not a musician. So if you're not a guitar player, you are not a musician. Is that true? Maddie says no, that's false. You agree? Give me a counter example. In other words, an example of when that is false. Okay. Yeah, so if it says if you're not a guitar player, so for instance, if you're a tuba player, then you're not a musician. So if you're a tuba player, you're not a musician would be one way of saying that. Is that true? No, that's not true. Okay? Right. Right, but what I'm saying is we could replace, like, if you're not a guitar player, we could replace that by saying, okay, someone that is not a guitar player would be a tuba player, for instance, right? So another way of saying, if you're not a guitar player, one example might be, okay, you are a tuba player. You're not a guitar player, but I know you wouldn't have to be, but let's say you're not a guitar player, you're a tuba player. They're saying if you're a tuba player, you're not a musician. Dude, that's false. All the tuba players out there are going to form an alliance and get mad. Okay? Letter D, if you're not a musician, then you're not a guitar player. Okay? Well, if you're not a musician, then you can't be a guitar player, right? If you aren't a musician, you don't play music. So people who don't play music are not guitar players. Well, that's true. They might not be other things as well, but definitely not guitar players. Okay, very good job. Any questions on those? They're kind of weird. They make you really think. They kind of twist your mind up for some of us. Some of us don't think ever. We just know it. Okay? All right. Why don't you guys try this guy right here. Write the negation of the statement. Work with your groupies. Wait, we're going to skip number 5. We're not going to go through the whole process of example 3 again. So just write the negation of 3. Hey, number 3 and 4 are two separate problems. Okay? So write the negation of number 3. And then write the negation of number 4. Hey, who thinks they have number 3? The shirt is green. The negation, Nathan? Good. The shirt is not green. That's the negation. The shirt is not green. Now, I like to think of it as a teenage attitude. Like your parent says, hey, your shirt's green. And you're like, no, it's not. And it actually is. But, you know, like if your parents say it, sometimes we just have to disagree. Okay? We're like, it's like some other type of green. What other green? Mint. Okay. Yes. Okay, so my bad. Okay? Yes, Danica. Yeah, the shoes are not red, so we would say the shoes are red. Now, just because I am trying to emphasize how I could go against the grain, I'm going to use blue to write the shoes are red.
Shoes are blue.
Okay? Shoes are red, just to really mess with our mind. Using blue. Next to red, which we talked about green.
No.
Messed up. I know. And I could have used green. I actually have green here too. I could have color-coded, but I didn't. So, that's all right. All right, think you got it? Isaac, you pumped? I can tell. Okay, moving on. Number 6 through 9. Give them a go. That thing for number 9? Yeah, new symbol today for those of you who don't know this one. This means perpendicular. Yeah, add it to your notes. Perpendicular. Perpendicular means, what is perpendicular? Yes. Yes, Carlo. Yes, Danica. Good. When they intersect at a right angle. They have to make at least 2 right angles. But yes, that is perpendicular. So they intersect at a right angle. Upside down T. Okay? Let's look at 7. JMF and FMG are supplementary. So JMF and FMG. So this and this are supplementary. Who says yes? Who says nope? Okay. Why is it yes, Carson? Yeah, it's true. Okay, it's true because they add up to 180. Okay, they make a straight line. Straight lines make 180 degrees. Yes, Alex?
Isn't there like a symbol, like a half circle?
Well, technically, all supplementary angles, you can do that, right? They make a half circle. Okay? A diameter is a straight angle. Okay? The point M, so you guys would want to justify here. Okay, I'm not going to write out the justification. I guess I actually have on this page, so I can do it that way. Okay, there's my justification. Linear pair of angles are supplementary. Linear pair, remember, they form a straight line. Okay. So the next one says, let's go back to that. Number 7. The point M is a midpoint of FH. Do we know that this is a midpoint?
No.
No, we don't. How come we don't know?
Because there's no lines in the middle of the first line.
Good. They have to have little markings, right? They'd have to show the bisector markings. They have to have these little symbols. Okay? And we don't have that. So we can't say that. So my explanation, I said false. Without markings, we cannot determine the midpoint. Okay? How about number 8? JMF and HMG are vertical angles. Is that true? Yeah, dude. That's a vertical angle to that one. Okay? Anytime you have lines intersecting, they always form vertical angles. Okay? I got really wordy with it. True because M lies on FH and JG, and 2 pairs of opposite rays are formed. So when you have an intersection, you get opposite rays. You could just say anytime 2 lines intersect, they form vertical angles. That would have been fine as well. How about the last one? Is that true?
False.
Yeah, that's false. We don't know that. How come we don't know that? Brennan? Yeah, there's no little square in the corner. Okay, no right angle marking. Without the markings, you cannot determine perpendicular lines. Okay, how many think you have it up to here? Okay. Guys, I will tell you that as we get a little farther in this lesson, it gets a little weirder. A little more weirder. Weird ifs. Okay, this one is not quite there, but rewrite the definition of a right angle as a single biconditional statement. Okay, I want you to go ahead and try number 10, right? It is a biconditional, so you got to look back to your notes about what a biconditional is. Okay, give that a go. Okay, remember, a biconditional only works if both the hypothesis and conclusion are true, and the converse and contrapositive, or excuse me, the converse and conditional are true. Okay, so if an angle is a right angle, then its measures is 90 degrees. Okay, that's true. And then if you flipped them and said, if a measure of an angle is 90 degrees, then it's a right angle. Is that true? Mm-hmm. So the converse and conditional are true, therefore we can write a biconditional. We could say an angle is a right angle, better than a wrong angle, if and only if, thanks for laughing, its measure is 90 degrees. How many got it? Okay, now that you kind of have it, or at least you've seen an example, I want you to try the number 11. Write the definition of congruent segments as a single biconditional. Okay, let's see how you did. Two line segments have the same length if and only if they are congruent segments. How many got it? All right, not too bad, right? Now remember, tell your neighbor what you have to have in order to be able to write a biconditional. Not if and only if. That's not what you have to have.
Both of them have to be like equal opposite ways.
Good. Two things must be true. What two things must be true? Yes?
The conditional statement and the converse.
Good. You can write a biconditional if the conditional and converse are true. Okay, guys, we're going to switch gears to truth tables. And I am going to explain these truth tables in a way that makes the most sense to me, because I think truth tables can be kind of confusing. So first thing I want you to write down is in your notes, I want you to write truth table. And this is my truth table. This is a conditional truth table. Okay? So I'll let you copy that down, and then I'm going to explain to you how we're using this. The best way to address it is if we can say, look, we're using the truth table, in this case, to prove a statement false, to try to find a counterexample. So if we approach it like that, it might make it a little easier to understand. Okay? So in order to prove something false, if we have a conditional statement, so let's go back to our statement like we had yesterday, or the other day when we said, if yesterday is Wednesday, today is Thursday. Okay? Let's say, well, we know if the hypothesis is true and the conclusion is true, then we have a true statement. We also know that if the hypothesis is true, but the conclusion to that hypothesis is false, that's a false statement. Most of us can agree on that. Okay? Where it gets a little weird is right here. Now let's look at it in this sense. If you read your hypothesis and you cannot, if it's false, we can't necessarily prove this statement false. Right? We can't go any farther with it because the hypothesis we're functioning on is false. So we have to stop there. We can't prove it false. It doesn't mean we necessarily can use it as a useful piece if you're using it in some kind of design or research, but we can't prove it false. Therefore, we're going to accept it as true for now. Okay, and the same thing happens here. So if you have a false hypothesis, we're going with true because we can't prove it false. Does that make sense? Okay. No, doesn't make sense. Okay. So like if we can't agree on a hypothesis, a true statement to test, then we can't actually test that, right? Like if our original statement, if the foundation we're trying to build on is false, there's no way to test that foundation. Okay? So we have to start with a true foundation in order for us to end up disproving something. Okay? It may not give us a valid conclusion, but we can't disprove it. Therefore, we're going to accept it as true. All right? Okay. Alex.
Wait, so basically,
No, that's not exactly. I mean, in terms of our truth table, we're going to accept it like that. Okay? But what I'm saying is we can't have a valid hypothesis. We can't continue with our argument. Okay? So in order to start the argument, you have to have a valid hypothesis. Okay? So for what we're doing here, this is a conditional truth table. What I want to do is I want to go ahead and list our converse truth table. Okay? So over here, let's go ahead and list converse. Okay? We're going to go with the same columns in converse, right? The only thing that changes with converse is we know we don't have P implies Q, we have Q implies P. Okay? So, still have our same pieces here. These don't change because we're not negating them or anything like that. However, now our hypothesis is Q. So in order for to see if our converse is true, we have to look here. So if this is true, and that's true, I'm going to kind of go backwards. Like here I said true, 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 false. Well, that's false, so it's going to give us true. We have to stop. Well, here I go true, true, so that's true. False, true, so this is our hypothesis, so therefore this has to be true. Okay? True, false. So if you have a true hypothesis but a false conclusion, that is false. So the only way to get a false statement is when you have a true hypothesis and a false conclusion. A true hypothesis and a false conclusion gives you a false statement there. Okay? And then false, false is true. All right, let's try inverse. All right, inverse actually negates both things, right? So this is going to be a bit longer table. We're still going to have P. We're still going to have Q. But we're going to add two new columns. We're going to say not P, and should have given myself a little more room here, and not Q. Okay, and then the actual inverse, the final statement would be if not P, then not Q. Okay, so once again, P stays the same, true, true, false, false, as in our conditional. Q becomes true, false, true, false. It doesn't become, it stays the same. Well, not P actually becomes what? So if it was true, it's now false. You're just switching it. So if P was true, it's now false. P was false, it's now true. You're negating it. Some of you will think of it like multiplying by a negative. Okay, that's a true statement. You just switch them. Q was true, so now it's false. It was false, now it's true. True, now it's false. And false now is true. Okay, so now if we're just focusing in on these two columns right here, false, false gives us true. A false and a true gives us true. But a true hypothesis and a false conclusion is false. And the other one is true. Okay, we've got one more, the contrapositive. Now, while you're figuring out the contrapositive, I'm going to be handing out what we're going to be doing today. Now, just so you understand, on the contrapositive, you're going to have these same columns. It's just, what's your final statement here? Alex?
Negative Q, arrow, negative P.
Good. All right, so everything else kind of stays the same here. Right? It's just when we're reading it, we're reading negative Q first and then referencing P. So these pieces, they stay the same. So opposite of P is false, opposite, false. So that's true, that's true. Q, that's false, true, false, and opposite is true. So when you go through and read this, we now have if false, then false. That's true. If false or if true, then false. That's false. If false, then true. That's true. If true, then true. That's true. Kind of weird stuff there. Truth tables? Could be. Okay. Hey.